If you love space science and astronomy news, check out my 60-second short videos every weekday. In case you missed them, here's all the daily videos in one cut. There was a ton of great stories this week, but of course there's a ton more out there just waiting for you to discover them on your own. Please follow, drop a like, and consider subscribing on YouTube to support the channel and so you don't miss another space science update. How many satellites could be orbiting Earth in 10 years? If you guessed 100,000, you're right. The rise of megaconstellations like Starlink is leading to largely unstudied impact on our environment and our ability to do astronomy from the ground. We've talked about this in a previous video, but now a group of astronomers from top universities has written a letter to the FCC urging them to overturn a 1986 ruling that exempts satellites from the need for environmental impact studies. Megaconstellations are constantly being replenished as technology moves on and the old satellites are burned up in the atmosphere. The effect this has on our environment is very unclear, and the impact of such megaconstellations on our ability to do astronomy from the ground is also largely unstudied, but almost certainly bad. The astronomers from places like Harvard, Princeton, and Berkeley are asking the FCC to halt further megaconstellation launches until these two issues can be studied in detail and the true environmental impact assessed. I have to say, I agree, this is an issue that's long overdue for review, but what do you think? Let me know down in the comments. That's how the world's first wooden satellite was launched aboard a SpaceX resupply mission to the ISS on Saturday. LignoSat was developed as a collaboration between Kyoto University and Sumitomo Forestry to test the suitability of wood as a space material. The small CubeSat is made from a type of Japanese magnolia tree called Hinoki and will spend about a month on the ISS before being launched into orbit. During its 6 months on orbit, the satellite will return data on its structural integrity as it experiences temperature swings of 200 degrees Celsius every 45 minutes. It'll also measure how effective the wood is at shielding its electronic components from radiation in space. Wood may be more durable in the vacuum of space than on Earth due to the absence of water and oxygen, meaning it's unlikely to rot or catch fire. Another big advantage is a reduction in the emission of toxic chemicals and metals released into Earth's atmosphere when wooden satellites are eventually deorbited. This growing source of pollution is a very poorly understood threat to our planet's environment, as we discussed in yesterday's video. Astronomers have spotted a black hole in the early universe feeding on its surroundings with a serious hunger. As material falls or gets pulled into a black hole, it starts to accumulate in a disk and heat up, emitting radiation including X-rays. There's a theoretical limit called the Eddington limit to how fast the black hole can grow because the pressure from the radiation being emitted by the infalling material resists the pull of gravity from the black hole. Using JWST and the Chandra X-ray Observatory, astronomers measured flows from this new black hole called LID 658, moving at 500 kilometers per second. When coupled with the X-ray data, this black hole is growing at around 40 times the Eddington limit. These kind of events have been seen before and don't necessarily violate the laws of physics since it's thought that they only occur in short bursts. However, these rapid accretion episodes could explain how black holes in the early universe get so massive so fast. Astronomers estimate that LID 658 started out as a 100 solar mass black hole 12 million years ago and now stands at 7.2 million solar masses. That's quite an appetite. Tardigrades are amazing microscopic creatures that can survive for years in some of the harshest environments in the universe without food or water. Life in a vacuum? Piece of cake. Extreme temperatures? No sweat. Radiation environments that would melt a nuclear reactor? Tardigrades love it. Scientists have been trying to unlock the secrets of tardigrade resilience for decades, hoping that understanding these tiny animals might help with everything from space exploration to cures for cancer. Now, researchers in China may be a step closer to some answers. They've discovered a new species of tardigrade with around 2,800 genes that become more active when exposed to high levels of radiation. These genetic defenses help protect the tardigrade's DNA and even help it repair some of the damage through various mechanisms. Tardigrades have already survived multiple trips into the vacuum of space aboard international missions, showing a remarkable ability to suspend their metabolism for extended periods. Hopefully this research may bring us closer to unlocking the mysteries of the tardigrade and bringing new insights into humans surviving long-term spaceflight.